In Section 5 of Chapter 5, we're going over the greatest common factor and factoring by grouping. And we're looking again for strategies, and hopefully you have did well on your quiz and lesson. So let's start with 1A here. Now, the way to figure out common factors is to factor 4 into its prime factors. So 2 will go into there, and you're left with 2. So these are prime factors now. Then we have 24. 2 out of there is 12. A 2 out of there is 6. A 2 out of there is 3. Now, what is the greatest common factor that we find in each of these terms? 4 and 24. Well, here, the 2 together is a 4. So that's found in the 4. And then there's also a 2 and a 2 and a 4. So for the greatest common factor for these two numbers, it is a 4. And this was a very easy one. You probably could have figured that out right away. Now let's do the 15 here. We got a 3 and a 5. And let's take the 20. We've got a 2, a 10, a 2, and a 5. So the greatest common factor that's found in both of these is a 5. So for this one, it's a 5. Now here we have 15 and 20, so we know as part of the number, that's the greatest common factor in each one, is a 5. We figured that out over here. And now we have x squared, that's 2x's, and here there's 1x. So you could take an x out of each one of these as a common factor, so 5x. And you could do the same with the 9 and the 27, but 3 times 9 is 27. So the common factor of the number here is 9. Now here we have x to the second x, so the common factor of x, the x's would be just a single x. That would be a common factor in both. And then a common factor of y in both. Okay, and then you'll have some practice on this as well here. We'll raise this up a little bit here. Now, what they're asking us to do here is take out the common factor in each of the terms, and it's sort of the reverse of the distribution, the distributive principle that we spent earlier. So we often start by putting a parenthesis. I guess I have the wrong pen there. There we go. Now, what factor can we take out of each of these? You could take a 2, but that's not the greatest. You can take a 4 out of each one. So if we take a 4 out of this, we're left with a 4x. And if we take a 4 out of the 12, we're left with a 3. And if we use the distributive principle, we get back to what we had. And inside the parenthesis, there's nothing else that we could factor out. Now here, as we look at this, for the number, we can take a 28 out of each one. And here we're left with an x. And you might say, well, you've taken the 28 out. What's left here is a factor. And the answer is a 1. Because when you finish, you ought to be able to go back and get what you originally had. If you didn't put a 1 there, you would never get back to what you had. Okay, parenthesis. For the number part, we can take a 5 out of each one. And there's a z here, and z's there. So we can take a single z out. So we put a 1 there, minus 5, x, z to the third. And again, if we multiply, we get what we had up here. Now here we have 3 terms, and we can do it on top too. What can we take out as far as the number from each term? Well, we could take a 6 out of there, but not out of the 9. So we could take a 3 out of each term. And there's an x, x, x. The largest number of x's that we can take out of each term is just the 1x here. So 3x. So 3x out of there leaves me with a 6. This leaves me with 3x minus 2x squared. Now notice what's left inside the parenthesis. There's no more common factor. And here we have 4 terms. So let's see what we can take out of each one. 18, 12, 9, and 12. And it looks like, again, the largest we can take out is a 3. And for the letters, a to the third, a to the second, we can take out an a. A b to the second b, we can take a b out of each term. And then what are we left with here? Well, this is going to be 6a squared from this, minus 3 will go into 12 4 times. And we've taken out the AB already, so there's no letters left to take out. This is going to be a 3. We've taken out an A and a B, so we're left with a single B. And here we're left with a 4 and an A. Okay, that looks good. And you can always check them. Now, for something like this, you might say, what's a common factor? Remember, there's a 1 in front of this. So in a sense, this is a common factor. So, if you recall from an earlier lesson, we said we could then say 3x plus 1, that would be this 3x plus 1, put that in a parenthesis, and then now our common factor is y minus 5. Because if we wanted to multiply this, we said a way to do it would be take the 3x and multiply it by this, and then the 1 and multiply it by this, and that's what they're showing. So to reverse that, this is how we would do it. Now, another method of factoring is factoring by a process called grouping, where we group what we have into 2 groups. And we see, is there a common factor here? And you might say, yes, there's a y. And then I get x plus 1. Now, is there a common factor here? Yes, we could take a 5 out of these 2, and we get x plus 1. Now, reminder of what we just did up over there, we could then take out the y plus 5, this y and this 5, and then we have this as a common factor. And you might say, could you have written the x plus 1 first? Absolutely. These can be switched around. So again, we're going to factor by grouping. What can we take out of the first two terms and then later the second two terms? Here we can take a 2 out. And we're left with y minus 6. Now, what we're looking for in these second two terms is this common factor, y minus 6. In order to get these to become this, I have to change the signs and take out a common factor. So if I take out of these a negative x, notice when I multiply through, I get this. So taking out a negative something will reverse the signs here, and now I have my common factor. So this would be 2, I'm getting carried away here, 2 minus x, this 2 and this minus x, and then the common factor y minus 6. And again, to check it, you would go from this to this, and then multiplying through here, you get this. Okay, we want to take out a common factor from these two, and then later these two. So what can we take out here? An x. And we get y plus 9. Now again, we want a y plus 9 out of these two. In order to get that, I have to take out a negative 7. So then I get, in one parenthesis, x minus 7, and then my common factors, y plus 9. Now, here are our two terms. We're going to factor by grouping. What can I take out of these two? Well, a 5x. And then I'm left with y minus 2. And if I want a y minus 2 out of these others, what do I have to take out? A 7 plus 7. So in writing this, then I get 5x plus 7, and then my common factor out of each, y minus 2. And I've done this through the process of grouping, which is a good method to be familiar with. Now, here are some general examples of things to do. What can I take out of each term here as a number? Well, I can take out a 4. And in terms of the letter, out of each term, I can take out an x. So I'm left now with 4x squared minus 3. So out of each term, I'm taking out a 4x. And then if I distribute, I get this again. So it's a way to check. Now, here, of the number, what can I take out? Well, I can take a 9 out of there and a 9 out of there. So I will do that. So I take out a 9 for my number part. And then for the letter part, I can take out an x and a y from each term after I study it a little bit. So this will be a negative y squared. Just checking that over. Yep, that looks good. And this will be a positive 2x to the third. I've already taken out the y. Now this one, it's 4 terms. Is there something I could take out of each one? And you might wonder, could I do this by grouping? No, I don't think so. So we're going to try to see what we can take out of each one. There's an 8, a 12, an 8, and a 6. We can take a 4 out of these, but not out of that. So the most we can take out for a number would be 2. Now this is a to the second, a. So we can take an a out of each one. And a b. No, we can't take any b's out because these terms don't have b's. C. And we can't take a c out of because this last term doesn't have a c. So the most we can take out is an 2a. Then this becomes 4. A b squared c minus 6. The a we've taken out, and we get b squared c minus 4. We've taken out the a, so we're just left with the c. And here we're taking out a 2, so we're left with a 3. We've already taken out the a. Okay, and that's as far as you can go. Now here we see we have common factors here. So we can, this is like the second stage of grouping. So we have 9y minus 4. And then we have z plus 2. Now here, again, there's 4 terms. There's no common factor in all of them, but here, if I take out a 2 from my first two, 2x, I'm left with 2y. No, I'm just left with y here. Thought I was on a roll there. Yeah, I'm going to take a 4 out here. A 4x. There, that's better. Then I'm left with a plain y here, minus 2. That's it. That's better. And then from these two terms, I'm going to take out a 7, and I get a y minus 2. All right, that's better. So 4x plus 7, and then y minus 2. Now, for this one, I'm going to work on these first two, because you can't take something out of every term. I'm going to take an x squared out of here and get x plus 5. And there's already an x plus 5 there, but I can take out from every term a 1. So of this, I'm just taking out a 1, which I can take out of any factor. 1 times this doesn't change it at all, but it lets us factor it nicely. So we have x squared plus 1 and x plus 5. Okay, well, this was a little bit shorter than our usual, but hopefully through practice and your quiz bees as we wind up our Math 1103 class, you're getting some practice.